A buffer solution contains a weak acid mixed with its conjugate base. So we get a weak acid and its conjugate weak base, or a weak base and its conjugate weak acid. A buffered solution is a solution that resists a change in its pH when either a strong acid, so H plus ions, or a strong base, so OH minus ions, are added. The most practical example of a buffered solution is our blood. It can absorb the acids and bases produced in biological reactions without changing its pH very much. A constant pH for blood is vital because cells can survive only in a very narrow pH range. As you can see from this diagram here, your normal pH is going to be somewhere in, so it's going to be in here somewhere between 7.35 and 7.45. If it gets too low, you have something called acidosis, and if it gets low enough, you die. If it gets a little high, it's called alkalosis, which can make you very sick. And then again, if it gets too high, you can die. So buffered solutions are used in medicine a lot because when you take medicines, you want to make sure that the medicine is not changing your pH drastically. So a buffered solution may contain appreciable amounts of a weak acid and its conjugate weak base. So for instance, it might contain HF and sodium fluoride. Now obviously the sodium ion part isn't important. So it might contain HF and F minus, a weak acid and its conjugate weak base. Similarly, it might contain a weak base and its conjugate weak acid. So NH3, its conjugate weak acid would be NH4+, which you might see in a compound like ammonium chloride. But again, we don't care about that. It's just the ammonium ion, so a weak base and its conjugate weak acid. By choosing the appropriate components, you can make a solution buffered at almost any pH that you want, and we'll hear about that in other videos.